This is StarTalk, Cosmic Queries Edition. And today we're going to dip into chemistry. Ooh. Chuck, you with me here, Chuck?
I am.
Yeah. How you feel about chemistry, Chuck?
I'm waiting for you to dip into it. That's
Okay.
I have to say that I had a terrible chemistry teacher and ruined the entire experience for me.
You're the walking wounded of chemistry.
I am
students.
the walking wounded of chemistry, and I won't say his name, but I remember him vividly, and he would explain something, and then immediately expect us to know, like, what the next thing is, and he would do this, and everyone would sit in the classroom, kind of like in this terrified state, because it's terrible to feel like completely ignorant, and it's worse to feel stupid, because ignorant is one thing, but you feel stupid when somebody has an expectation of you that you're not meeting.
Damn, Chuck, are you still in therapy for this?
I am.
This sounds like you got a lot to shake.
Right. So then, wait a minute. Then, me,
I asked, okay?
I say what's on my mind. So he didn't like me because he asked a question and we hadn't covered it, right? And so I said to him in front of the whole class, "You do realize you have a degree in chemistry. This is high school."
And then he said, "What are you, a comedian?" And I said, "Well, as a matter of fact."
And the rest is history.
Well, neither you nor I carry any kind of significant chemistry expertise, so we went out into the ether. Oh, yeah. And we found Kate the Chemist. Kate the Chemist, welcome to StarTalk.
Thank you so much for having me. I'm very excited to be here.
Yeah, excellent. Can I introduce the lady, please?
No, I was just going to say, I can already tell you're going to make me like chemistry. Just the name, Kate the Chemist. It's like,
Kate the Chemist.
I'm like, I need to hear more.
So you're that's what we call you on the internet, but behind, part the curtains, you are Professor Kate Biberdorf, and you're on the faculty at the University of Texas at Austin in their Department of Chemistry. So this is just way excellent. And you've written books, previously just for kids, but recently you have a book that came out a few months ago for grown-ups. So that's cool. I would have to get the title here. It's Elemental, The Hidden Chemistry of Everything. I love the title. And so, Kate, let me ask you, is this finally grown-ups get to create a fire in the carpet in the living room?
Yes,
have the
exactly
permission?
what it is. Yeah, that's what the book is. And I teach you how to do fireworks right in the middle of your living room.
That's everybody's memory of the chemistry kit growing up. But the kids
I hear
do
that
it
all the time. I hear all the time. The parents come up to me after these shows because I blow stuff up for kids, and they keep asking me these questions, and they're like, "My little kid has this question about sunscreen." I was like, "Your 5-year-old has a question about sunscreen," and they're using their kids to ask the questions. So in the book, I literally just went through and answered all their questions that they've ever asked me.
I got you. Okay, cool.
In fairness, it could have been a very vain 5-year-old.
That's true. That's true.
It's like, I got to keep this tight. I have got to keep this tight. I know I'm 5, but I'm thinking ahead.
So what is Kate the Chemist fiction series? What is that?
There are 7 books, so 5 fiction ones, and then there's 2 nonfiction ones. But the fiction series is this little 10-year-old named Kate the Chemist, and she goes around her neighborhood and solves any problems in the neighborhood using science. And it was just so fun to write because for the first time ever, I could make stuff up. Like, you can't do that in the chemistry world. You can't lie about things. And so here I could just have little kids breathing fire, and it was just an absolute blast.
So what is one scenario that might be solved with chemistry in terms of a mystery or a problem in a book series?
Yeah. So the very first one is called Dragons versus Unicorns, and it's the little kids
Very
musical.
scientific. Very scientific.
It is.
Very scientific.
Wait, Chuck, she says she made this stuff up, and it is called fiction.
Okay.
Right.
Chuck,
And
learn the definition of the word fiction, Chuck. Okay.
Well, to be real, honestly, that's kind of the reason why is they're trying to get people who might be intimidated by science. Like, some kids don't want to read a science book, but they might want to read Dragons versus Unicorns. And so it's a way to kind of hook kids, especially little girls, and get them excited about science. And in the series, little Kate goes around and she's kind of the director of the musical. And there's all these problems, like the unicorn's horns fall off, and so she has to make glue using science to get it to stick so it'll stay on the forehead. So there's a lot of little ways I can sneak it in there. And it's just a blast. I had so much fun writing.
Well, I thought you would tell me what dragon breath is made of. See, I'm not happy.
Sure, I can tell you.
Okay.
I absolutely can tell you.
Okay.
That's also in the book. That's also in the book. And
really?
so, yeah, it is. And so what she does is, so in the very beginning, we have the little girl breathe fire, and it's just this big experiment, and so it was really exciting, but they wouldn't let her do it in the musical, so it's a big deal. So they end up using Cheetos and liquid nitrogen. So you dip the Cheetos into liquid nitrogen, give it a second, and then you can bite down in it. When you exhale, you end up breathing. It's gas, it's smoke, right? And really condensation. But yeah, there's a little bit of dragon breath in there.
Okay, so it's smoke dragon breath, not flame dragon breath.
No.
Okay.
The editor had a little bit of a problem with that. So.
As a chemist, if dragons actually breathe fire like smog, right? So
I mean, as in the desolation of smog.
as in the desolation of
story.
smog. So
Yes.
smog, you see his belly actually glow red, and then the inside of his throat becomes very hot, and then boom,
It becomes radiant and
Radiant.
it's ready to come out. Yes.
and then there's a
okay.
plume of fire. From a chemist standpoint,
Yeah, Kate, explain that.
What would be that fire? I'm serious. How would you justify that scientifically? Now, come on, we know we got to suspend disbelief, but if we could justify that scientifically, what would be that fire?
Well, I can tell you what fire is. Fire is a combustion reaction, and it's anytime you have a source of fuel, you react it with oxygen, and then you form carbon dioxide and water. That's a traditional one. And so what you're seeing is the release of that energy exothermically being shot out. I breathe fire using cornstarch, which is a lot easier, a lot safer, but that doesn't start in my belly. I just put it in my mouth and spit it out.
Well, you're saying there's a safe way to breathe fire. That's you just said that. Okay. As opposed to the dangerous ways of breathing fire, I can do it safely.
True.
All right.
Yeah.
Okay, how about this? I got one.
cornstarch-
I got one. Okay, so as we all know, there are anaerobic microbes deep in our gut, and they release methane. Normally, the methane comes out the back end, but if you could somehow reverse that tube and then have it come out of your mouth and then ignite it, then you could breathe fire with methane, a gas that you produced yourself.
So there you have it. Basically, dragons have flatulent mouths.
They're fart faces. Is it?
Exactly.
I said it for you, Chuck.
There you
fart
go.
face.
That was the joke. So thank you.
Yeah, normally I don't steep lower than you go, but I did it just I did it.
I'm always getting the letters.
It's true. It is true.
Why are you always trying to bring Neil deGrasse Tyson down?
That's so funny.
Oh, all right. So this is actually a Cosmic Queries edition because we hardly ever have chemists, and I'm embarrassed by that because chemistry is some of my best friends are made of chemicals, and so we need more chemistry in this show. And Kate, for those who are seeing us on video, you are graced on your back wall by, of course, a periodic table of elements. But that looks a little different from ones I'm familiar with. Did you steal that from where'd you get that from?
Etsy. I ordered it off Etsy. I found one. I was looking for something for my back wall that wasn't too busy or crazy, and I'm not very artistic. I don't like putting things up on my walls, and I stumbled upon this. It's a periodic table from 1963, so it's organized a little bit differently. You don't have the lanthanides and actinides at the bottom, which people are traditionally used to seeing.
Of course not. I was going to say that.
Of each other.
I was going to say that myself. Yeah, it
I know.
clearly
I said it for you. But my husband.
Yeah, I'd let you say it.
chemist.
I was going to
Go
let
ahead.
you say it because you're the guest. Yeah, okay.
Thank you. I appreciate it. But when I first got it, my husband and I stood here and looked at it for like 30 minutes and talked about all the different pieces, and I just love it. It's my favorite thing I bought during the pandemic.
Wow.
Cool.
Wow, that is a nerdy marriage, boy.
I know.
Wow.
You're not that wrong. That's what's so sad about it. It's like it's so fun. I love it. Isn't it beautiful? It's beautiful.
It's beautiful. It's beautiful in a geeky sort of way. It's beautiful.
Right.
Yeah. Yeah. Well, if you got your own following, geek following, you got to be card carrying geek all the way.
That's it.
So
100%. I'm all in. Yep.
yeah. So Chuck, you collected questions from our Patreon members because this is a Cosmic Queries.
That's right.
And Kate, I'll be coming back to you about your periodic table and intermittently because me and periodic table go way back too. I got
Neil's another lover of the periodic table.
Oh, don't get me started on the periodic table. But okay. What I want to do, I want to try to, because I know the periodic table through the lens of an astrophysicist. So, and Kate, you clearly are a chemist with your periodic table. I'm going to come at you with some astrochemistry. Just to see if you can hang with the astrochemists. All right, we're going to try that a little
bring
later.
It on.
We're going to have to go into the octagon for this one.
Oh my God. 2 nerds enter and they both leave, but just one of them with a little more respect.
Yeah. Hilarious.
It's Nerd Thunderdome.
I would watch that.
Yeah, me too. All right, so what do you got, Chuck?
All right, let's just jump into it. Who we got here? We have, I like this, the artist formerly known as James Smith. Hello, Dr. Tyson, Dr. Biberdorf, and Chuck. Chuck, if you mess up my name, you should just give it up, buddy. Bro, I really got to read these beforehand, I swear. Here's my question. Where do we find lithium on Earth? And how can we find more of it? Does it exist on other planets? I love you guys. Have a great day.
Let me give a handoff to Kate on this. It is made in tiny quantities in the Big Bang. Very tiny quantities. But it is made, unlike most other elements that have to wait for billions of years for stars to create them in their cores. The Big Bang itself makes a little bit of lithium. Now let me hand that over to Kate.
So it's OG. It's an
original gangster.
Lithium. I've been here from the beginning. Don't call it a comeback.
Kate, we need a column, the OG elements. We need that,
elements.
Kate. Oh, yeah.
I love it. I love it. Oh, that's really funny. I'm gonna have to pitch that. We'll see what people say with that one.
Yeah.
Lithium is like most of the other metals. We find it in an oxide form a lot of times in mines. I believe lithium was discovered back in the 1800s in Sweden, and it was formed with an aluminum silicate as well. So there's a little bit of aluminum there and a little bit of silicon mixed in. So it's in the mines, just like all our other metals. We find it deep in the crust of the earth.
So you're saying it doesn't come in its own veins through the crust? It's mixed in with other elements?
Most of them are not. I know that we do have it in oxide forms. I don't know if we can find it by itself. It's very possible, but the forms I know of it are in the oxide form. So there's an oxygen attached to it somehow, which makes it stable because otherwise it'd be extraordinarily reactive. So
before we move on, let me ask you guys both this. So if iron is our core, do we find
the core of Earth?
Yes, the core of Earth. Sorry. If that's our core, do we find different elements at different levels, or is it just kind of all mixed in? And then, how's it work in terms of like as you get down to like the iron? Do you find different things at different levels as you go down?
Chuck, the heavy stuff is in the middle, and the light stuff floated. That's all. It's not that complicated.
Is that it?
That's what
Jesus.
yeah. It's seriously that easy.
Is it really that easy?
Wait. So Chuck, wait. Just to be clear, we think of rocks as heavy because they like sink in the water, but the water is floating on the rocks, and the rocks are floating on everything else that is heavier than they are that went to the center of the Earth. So rocks are light by comparison. Mm-hmm. Yeah.
Gotcha.
Yeah. No, so here's a question, Kate. How do you get why didn't all the iron go to the middle of the Earth? How can we have these ores of iron that come up into the crust?
Yeah.
Well, it has to do with attractions, right? Every single one of these atoms have protons in the center and electrons on the outside, and it just has to do with what it interacted with on its way down to the center. So if it sees a lot of the oxygen, it's going to have a reaction with that. We all know rust happens so readily here, right?
Right,
so things are going to rust out at certain points before. Exactly, yeah. So it's what it interacted with. That's what chemistry is all the time. What is in its environment? What's its system? What's its surroundings? What's going on around it?
So when we find these ore deposits, they're just distracted iron, basically.
Yes,
Iron.
They were on their way. They were on their way, and just like, what's that? What's that over there?
What's that? What's that oxygen atom? Check out.
They're like, hey, oxygen, what's up?
Too late. Bam.
Oh,
Frozen into
Oh, damn it, I missed it.
Midnight train to Georgia just left. All right, wait, we got to take a quick break. When we come back, we'll pick up our cosmic queries with Kate the Chemist on StarTalk. We're back, StarTalk, Cosmic Queries with Kate the Chemist. We're talking about chemistry, something we don't do often enough, Chuck. I think that this is, we do so many other things, and we got to give some chemistry its due. And so we got Kate, professor of chemistry, associate professor of chemistry?
Of instruction,
at the University of Texas at Austin. And we're delighted to have you. You're Kate the Chemist. And what are your social media handles?
I am at Kate the Chemist on Instagram and TikTok. I just hit 100,000 followers on TikTok, which I'm so excited about. Which I know is not a lot for you guys, but for me that makes me very happy.
No, 100,000. Excuse me.
100,000 is a lot for anybody.
That's for anybody.
I just made a mental note. I got to get on TikTok.
Yes, please get on TikTok. It's so fun. I really enjoy it. It's a very easy way to communicate science with other people and just give them little snippets, and I'm really enjoying it. I never thought I'd say that ever, but I'm really enjoying it.
Yeah, very cool. Cool. All right, so Chuck, what do you got for us?
All right, let's just jump.
These are still Patreon members, right?
All Patreon.
Yeah, all Patreon. We changed the rule. They're the only ones who get to ask questions.
If you are interested in asking us a question, Patreon is the way you have to do it. It was a way for us to kind of democratize. Actually, just the opposite of that.
Just the opposite.
Just the opposite of democratize. I'm sorry. It was a way for us to cull the pool.
It's not to democratize, to monetize. That's the word. All right.
Exactly.
All right, go for it, Chuck.
Here we go. This is Max Madison. He says, hey, Dr. Biberdorf, why do you think many scholars, including Isaac Newton, believed in or practiced alchemy even as recently as the 1900s? Do you think it was for greed, or was it truly for the pure pursuit of science?
Ooh, good one.
Yeah.
Plus, Kate, I would add to that, so from the alchemy I've read, there seemed to be some mysticism in there as well, at least if you go far back. So how does all that square, working its way so deep into the Industrial Revolution, for example?
Well, it's really funny because from a chemist point of view, when we think of alchemy, it's just more of the study of chemistry before we knew what was going on. And it was just people mixing things together and trying to kind of cook here and there. And sometimes they came up with medicines that were helpful, and sometimes they came up with crap that was not helpful at all. And so it just depends on kind of where you fall. And so for me, when I think of it, it just is like the chemistry before, the 1900s, before we had any clue what was going on.
So now with that, is Eye of Newt on the periodic chart?
Yes, here it is.
Have you ever seen? I saw this comic once. It was vegetarian witches, right? And so it was eye of potato, head of lettuce.
That's funny.
Oh my god.
That's pretty funny.
That's awesome.
Yeah, it was. So that's a really good answer. I like that. So what you're saying is, it's the best people could do before they really knew what was going on. But why is it such an insult, though? When you say, you're just an alchemist, and it's like people will fight you if you call them that. But you're saying that it should not carry a stigma.
I don't think of it. Yeah, exactly. Like, I don't honestly think of it with a stigma. I think of it as people doing the best they could with what they had. I mean, this was pre-internet. This was before we were sharing information so easily. This is just what they had available to them.
Okay,
so
Kate,
I don't
Kate,
think anything negative. Mm-hmm.
I don't want to have to school you in this way, but we are post-internet, and there are people who think Earth is flat. So don't think the internet fixes stuff, okay?
No, that's not what I meant.
That is exactly what you meant.
No, it's not. It's a way of people to communicate, for scientists to tell each other and share information more readily, and that's all I mean by it. And so before we had that,
you
it was
have an
much more
elitist
difficult to
internet.
actually do it. You'd have to go. Well, you'd have to go to the library, and you'd have to read a book, and you'd have to find that very specific book. And so it's easier to find that information in the internet. That's all I'm saying. But yeah, maybe.
Okay.
Right on. See, she's on the internet for smart people. Okay.
And for everybody else, we
that's
got
a whole
flat
nother-
earthers,
Exactly.
vaccine deniers.
Yeah, see,
we
'cause
got
we-
all the.
Right.
I have a hard time with
We are on the DAI, the dumbass internet. That's what we are on. The DAI.
All right, what else you got, Chuck? Give it to me.
Here we go. This is Elias Siametis, I think. Okay.
How you spell it?
Siametis. So either Siametis or Siametis.
Siametis. All right, I'll give you. You got a 50% chance
It's a
on that
50% chance, right? And Elias, if I messed up your name, change it. Anyway,
Chuck don't play. Chuck. Make my life easier.
there you go, man. All right, here we go. Hello,
right.
Dr. Tyson, Dr. Biberdorf, and Lord Chuck. Oh, man, look at you. What are some fun chemistry experiments that I can do at home for my twins, other than the ones in your books, because we have done those? At what age do you think it is appropriate or beneficial to get them started?
Ooh,
Oh, well, let's
okay.
start with that one immediately. As soon as they can start talking, I think it's really important to get that inquiry mind, try to ask questions. And I think it's really important, too, to announce that you don't know everything. And it's okay not to know everything. As a scientist, that's what we're doing, is exploring. We have questions, and then we're searching for answers. And so if you can kind of break down science into that right at the young age, then kids love science. It's all fun about explosions and exploration. What I would highly recommend is try elephant's toothpaste. That's not, well, it's in the kids version is in my book, but do the big kid version. Grab 35% hydrogen peroxide from a medical supply store. Order potassium iodide off of Amazon. Don't use yeast, because yeast isn't going to do anything, but order potassium iodide. Use dish soap. Make sure it's not natural dish soap. Natural dish soap doesn't have high surfactant in it, so it doesn't bubble as much. And so, like, Dawn dish soap is fantastic. Add some food coloring. Use a big flask. An Erlenmeyer flask is best, and add it right together. Add potassium iodide last. It's going to shoot out the top as the hydrogen peroxide decomposes. I mean, that's
Everybody
just a winner.
loves that. Everybody loves
It's
that.
it's
Love
easy.
that. Kids love it. You know.
Well, doesn't it make-
Outside, it'll destroy your ceiling.
Doesn't it make a big mess?
Yeah.
Yes.
Oh,
But there's
so-
tarps, and there's also things like you can wash stuff outside. No big deal.
Did you see the internet video where they did a version of that where it is almost half a city block that they filled with that?
What?
Yeah.
What?
It's insane. They made a set. It's like half a city block as a square, a half a city block square.
Wow.
And they just did they filled the whole thing. It's insane. It's insane.
It is. It made me so nervous because they did one right before that where I don't think their safety was up personally. Like, it got too close to them. I don't think they were wearing anything. It made me so nervous that they were going to get just covered in this stuff, which is just not good for your skin.
Yeah, that I saw that one too, and they're running away from it in that video. I'm like,
the house.
yes, I'm like, you people are insane. Yeah, okay.
Man.
But I'm glad they did. It was a cool video. No one got hurt, so that's all I care about.
But wait, Kate, does that mixture have any utility at all other than the demonstration of a geyser?
Well, to be honest, I use it in my classroom to talk about either stoichiometry or catalysis. And so you can talk about how you can use another molecule to come in and break apart a certain molecule into new pieces. Because what happens is hydrogen peroxide decomposes into oxygen gas and water. And it's extremely exothermic, so it's really hot. So your students can actually feel the heat. So you can talk about it in thermodynamics. You can talk about catalysis.
Yeah, okay. So it's very educationally helpful.
Yeah, it's very educational.
Instructive,
helpful.
yeah.
I'm going to say, I just want to stop you because I don't care if I don't know something. That's why I love doing this. Stoichiometry and catalysis, you sounded like you just told me I was going to die. You know? I'm sorry, Chuck, but you have stoichiometry and catalysis.
Oh, no.
You have 6 months to live, so I don't know what those are. I don't
let me
know what
break it
those
down.
No,
are.
our stoichiometry tells us that you have the catalysis. That's what
Yeah. Hilarious. Stoichiometry is just the chemistry version of dimensional analysis. So if you're saying, like, I'm going 60 miles an hour and I have 100 miles to go, how long is it going to take me to get there? That's dimensional analysis. So it's just basic unit conversion. Stoichiometry is you throw molecules on top of it. So you got a little carbon dioxide, you got some methane, and you just go through the math. And so you can do that with the decomposition and go through how much oxygen you would expect to produce. And it's a very fun, I say fun exercise because it uses the explosion. And catalysis, you've probably heard of catalyst before. Of course. So that's where you just have a new molecule and it takes two other molecules and brings them together. And so it's essentially it's like the highway for a reaction instead of the back roads. So when you throw in a catalyst, it allows it to go way fast and it's on a much faster route and it's just better, usually. Otherwise, it's a bad catalyst.
Awesome. That's great.
Okay.
Thank you.
All right. Good. All right. What's next, Chuck?
Here we go. This is Roman Prekup, who says, "Hey, Dr. Tyson and Dr.
Did they ever say where they're from? I always like knowing where they're from.
No, they didn't.
No, they don't say. Okay.
Yeah.
Right.
I mean, guys, if you want to start including that for Neil, that would be great. I will definitely include it in your question. Roman Prekup says, "Hey, Dr. Tyson, Dr. Biberdorf, Lord, nice. What is stopping us from using H instead of Li in L-ion batteries," which I believe would be a lithium-ion battery, right? Theoretically, they should be able to form the same connections with other elements, and H is lighter than Li. So hydrogen lighter than lithium. Is it only because H is the only S1 non-metal element? You know what? I was understanding everything he said right up until that point. Now you're just showing off, Roman.
Wait.
Roman?
I got to slip in here, get a little astrophysics. So you may remember on your periodic table, hydrogen is listed twice, right? Sort of as a gas and as a metal. Oh, we have a live demonstration of it there. So under very high pressures, hydrogen takes on the properties of metals. And in the center of Jupiter, which is 90% hydrogen, the hydrogen manifests as metal, and it conducts electricity, and it does all the things metals do, and Jupiter has a ferocious magnetic field as a result of it. But everywhere else, hydrogen is just like regular hydrogen. So, Kate, over to you.
It's a gas. So the main difference is it's a gas. And so lithium is going to be a metal. We can force it to be in the aqueous state so we can dissolve it in water, but hydrogen's a gas. And so that immediately changes everything about how it would operate. One thing we always talk about is how we could eventually try to replace a gas tank in a car with hydrogen gas. And so when I say gas tank, I'm actually talking about the liquid that you pump into your tank, whereas hydrogen
gasoline.
gas would
Gasoline.
be... Yeah, thank you. That's what I'm trying to say, gasoline.
Yes.
Whereas hydrogen gas is an actual explosive gas, and it would be really, really dangerous to put that on our car if we got into an accident, because now it would be a huge explosion. Like, that's unbelievably flammable, and if it's stored under pressure, it's super dangerous if it gets knocked into. So that's one of the biggest hiccups, is that it's a gas and it's flammable, so it's very dangerous, and we have to take care of it. All lithium's flammable as well, so there's pieces.
I was about to say.
Yeah, the lithium portion of flames too, doesn't it?
Yeah,
I was like,
yeah,
I got a feeling lithium might be in the same category, since they're telling me to take my battery out of my suitcase when I'm flying.
Okay, so maybe it's just not as flammable and explosive. Is that a fair characterization?
That's fair. That's fair. And it's stored under pressure, like you said. That pressure component really changes things.
Right.
Yeah.
All right. So then,
but just to be clear, and that S1 little ditty he put at the end there.
Thank you.
If I understand that correctly, Kate, correct me if I'm wrong, that lithium appears directly beneath hydrogen on the periodic table,
and
everybody in a column, in principle, can make the same families of molecules. And this is what all he was saying there, right, Kate?
Yes, that's exactly right. So both hydrogen and lithium have one electron in their very first shell, that external valence spot. So in the 1s shell, hydrogen has one. In the 2s shell, lithium has one.
Yeah. Okay.
Right.
All right. We got one.
Wow. I gotta say, chemistry is a lot of fun.
All right.
It is fun. I'm so
Kate
mad
is
at your
teaching
teacher.
Yeah. Oh my God.
When you were talking about that, I was ready to jump through the webcam and hug you. Like, it breaks my heart when I hear that chemistry teachers are awful. I hear it all the time. It's
Kate, you're not helping me here.
Yeah, no, Chuck did need a hug in that moment. This is true.
You needed a hug. You did.
Clearly I did, because I didn't even realize I was harboring all that until that moment. All right, let's go to Jim Kelly. And Jim Kelly says, "Hi, Dr. Biberdorf. When I took chemistry in college, it was the late 80s. I had a lab partner who told me the story of when the chemistry in high school, he mixed some things together that caused a cloud of gas to billow forth. My vague memory was that it was green. When the teacher saw it, he yelled to the class to evacuate immediately. Luckily, no one was hurt. I don't remember what he said the cloud of gas he created was, but I'm curious, do you have any idea what chemicals would be available in a high school chemistry class that could cause this kind of event? And what indeed was produced?" Hey, Chuck, you pronounce my name Jim. Man. You know what, Jim?
People don't have any confidence in you.
No, I know. That was wrong, Jim. That was wrong. What you did was
Jim,
wrong.
Chuck was having a hard day today.
I know,
and
man.
look what he did to you. So, Kate, you know any magic green gas cloud recipes?
Chlorine. I'm sure it's chlorine gas is what the teacher was afraid they made. So chlorine gas is yellow-green. It's not good to breathe in. It can go into your lungs. It dissolves in the water vapor that's in your lungs, and so it forms hydrochloric acid. So then you have acid in your lungs that can burn.
You're burning up from
and
the
there's
inside?
other stuff that can happen. Yeah, it burns. It's terrible. It's absolutely painful.
So Kate, if chlorine is a gas, but of course when mixed with sodium, it's just salt. Why do we fear hydrogen in a battery? If it's gas, but then if it mixes together with something else, it's no longer a gas.
Well, it depends on what the phase would be, right? And what its chemical compound would actually be, just like you're saying. Because if it's something with hydrogen partnered with another metal, it could be something that could be quite reactive. So in lab, we use something called lithium aluminum hydride. And so when the hydrogen actually has that electron, instead of giving it up and forming an acid or a proton, when it has that electron, it can actually be quite reactive and it's very dangerous. So when we use lithium aluminum hydride in lab, you end up having to take your flask and put it in a liquid nitrogen bath. So you soak it in something that's at 77 Kelvin or negative 194 Celsius because it's so reactive. So that my gut instinct is I don't want a battery with that.
Okay,
I don't want to be anywhere near that.
All right, but a little known fact that the orange fuel tank that was the main tank of the space shuttle orbiter when it launched, it had the two solid rocket boosters on the side, and then the main tank in the middle had two tanks inside of it, and one of those two tanks is twice the size of the other. Precisely twice the size, and the one that's twice as big had liquid hydrogen in it, and the one that was half the size had liquid oxygen in it, and you blend them together, they pick up a 2-to-1 ratio, and out comes the exhaust, which is just water. And so you're saying we can't do that in a car?
I don't think so, not safely. Have you ever been around those dewars? The dewars they're the vacuum sealed containers that you have to, in order to keep something in the liquid phase. So in order to have nitrogen, if you've ever seen liquid nitrogen, it's kept in these dewars. They're vacuum sealed containers because nitrogen wants to be in a gas in our environment here on Earth. Same thing with hydrogen, it wants to be a gas. You'd have to use a special container, which are ridiculously heavy. So on top of the fact that things are pressurized,
I just realized
do not see it happening in the near future.
I asked you a stupid question because, of course, those tanks, they're kept refrigerated until launch. Right. So you can't do that with a car.
There's that piece. Not in Texas. No, not here.
Well, yeah. You guys don't even have electricity. So.
Oh!
Blood drawn. Oh,
sorry. Had to do it.
Oh, all right. We got to take another quick break. We come back more with Kate the Chemist. As we're loving it because Chuck is learning some chemistry for the first time in his life. And so, all right, we'll be back in a moment on StarTalk. We're back, StarTalk, Cosmic Queries Edition, all about chemistry. It's our first foray with a pure chemistry episode here, and I'm loving it. And we got Kate the Chemist. Anybody that's named Kate the Chemist, you got to have him on the show, see? Because he's no one voluntarily just randomly calls himself the chemist unless they can mix some stuff together. And Kate, you met your husband in your chemistry department, correct?
I did, yeah. We were both getting PhDs in inorganic chemistry. We met in Welch Hall. He was behind me in our Saturday morning seminars and making jokes about things, and it made me laugh, and we fell in love.
Wow. But now he's in software engineering, correct?
Yeah, software engineering, he's coding. He's quite an
Okay.
introvert, and I'm quite an extrovert, so it's a pretty good balance. So
Yeah. So Chuck, so if you have a couple where they both are completely chemically fluent,
Right.
they have to really stay in love their whole time, because that could get really.
Yeah, you're not lying.
Here, honey, drink this.
Right, exactly. I was gonna say, yeah, that's a terrible. Yeah, you don't want to make your wife mad when she knows how to put together concoctions that will burn you up from the inside.
From the inside. This is 9
Easily.
episodes of CSI ready to
Right.
be written right here. Okay.
I'd have to be very careful about it, that's for sure.
And Kate, I think you only mentioned 2 platforms when I last asked: TikTok and was it Twitter or Instagram?
So yeah, Facebook, Instagram, and TikTok, I'm at Kate the Chemist. On Twitter, I'm K with the number 8, the Chemist. Someone else stole my handle there. So.
Ouch! All right,
know.
we got people. We can take care of that. Chuck,
Thank you.
Chuck,
Thank
call
you.
our people.
I will, without
All
a
right.
doubt.
Yeah, you'll have it in the morning. Okay.
Thank you. You guys, thank you so much.
All right, Chuck, give me some more.
Here we go. This is Sparrow Chaos. Sparrow Chaos says, "Hello, astrophysicist Neil Tyson and chemist Kate Biberdorf and Chuck. How does dissolving a salt molecule in water make its atoms ionize?"
Ooh.
Yeah.
Yeah.
Are you ready for this? Okay,
Yeah.
it's actually pretty simple. So what they do is they form what are referred to as ion-dipole interactions. And so the salt goes in, and it's in a lattice. So when you think of sodium chloride, I'm sure you don't think of it in this big like cage, but that's what it looks like. So there's a sodium ion, then a chloride ion, and then a sodium and a chloride, and sodium chloride, and they alternate. You
It's a
form this
big
giant
box.
cage. It's a huge box, exactly,
Yeah.
like a big cube.
Well,
And
so
you
the
drop it-
sodium atom is boxed in by the chlorine atoms.
They're all locked in. They're
Structurally.
completely surrounded in. Yeah, exactly.
Okay,
yeah, if you think
interesting.
Of like a cube, every other corner is a sodium, and then every other corner is a chloride, and so they just
Okay.
rotate because it's a 1-to-1 ratio.
I
And so
got it.
they're already technically in the ion form when they're in salt, because it's a sodium ion attracted to a chloride ion, and that's what forms the sodium chloride. So they're already together. And so when that cube drops into the water, they form the ion dipole interaction. So the ions from the salt, dipoles from the water, because water is shaped in this beautiful little point, kind of, if you will. So the oxygen's at the top, and then the hydrogens are directly below it. And so this forms an interaction with the salt, and they come together. It's called an ion dipole interaction in salt water.
I have to show off. It's a 105-degree angle. Is that correct?
It might be. I know it's less than 109.5 degrees because it's in the bent form. But
Oh,
it might-
okay. That's all I
105 might
knew.
be right.
I just had
Yeah.
to show off that little bit of thing. That's all I knew. Okay.
As far as
Yeah,
I'm
that
concerned, you're
sounds right.
talking about FM radio stations right
I know,
now.
109.5.
Okay.
But
Classic rock all the time. 109.5.
The Ion Station. Coming to you live right now.
So it's just lives that way. That is the natural state.
yeah, they break apart, and so the ions then kind of separate by themselves. So you have a sodium ion that's completely surrounded by water, and so since sodium is positive, it's going to be attracted to the oxygen negative side of water. So the O's are going to be surrounded. My Michigan just came out. My O's are going to be around the
O's,
sodium,
yeah.
and then the chlorine on the other side is negative, and so that's going to be surrounded by the hydrogen component of the water molecule. So it's completely going to arrange so all the ions separate out, and they're completely surrounded by tons and tons of water molecules, and that's what your salt water actually is.
Wow. It's
beautiful.
Ooh,
Okay, so the
my.
whole ocean is what you're saying.
Yeah.
Well, plus a lot of other crap. There's plastic in there. There's coral reef. There's
Plastic
fish,
and
there's oxygen.
fish poop. Fish poop. Especially.
yeah. Carbon dioxide these days. So
Yeah.
Boo.
Okay. Yeah.
I know. Sorry to go there.
All right. Yeah, she had to bum us out. All right.
Okay.
All right. So Chuck, what else you have?
All right. So let's go from a brine to a food question. This is this is Carrie.
That's Chuck's only chemistry word
That was
he
my
knows.
only chemistry joke that I
Brian.
could do. You're talking about okay, forget it. Carrie Manneberg says this. Hi, Dr. Kate and Dr. Tyson. This is a food chemistry question. Is it true cooking vegetables will reduce their nutritional value and denature some enzymes? Some raw veggies taste great, but when you roast a veggie like onions or carrots,
They taste even better.
They taste so much better.
So, Kate, what happens when some heat slaps onto some big vegetable molecules, or vitamins? Vitamins, I guess, is the nutritional part of this.
Yeah. Well, so the molecules for vitamins are either going to be fat soluble or water soluble. So it depends on how you're cooking them. So if you have a lot of oil in there, then the vitamins will dissolve in your oil or your fat. And so that will be pulled out. And depending on if you eat that liquid that's around there, it's very possible that it will dissolve out of there.
Wow. Okay. So if you knew in advance whether it's water soluble or oil soluble, you might cook your vegetables differently to avoid that.
Perhaps, but in general, the idea is just to minimize the amount of oil. You don't want that stuff in your body anyway. You don't want any of those fats. You want to minimize it because it's not good for your arteries.
Okay, but I bet what he's talking about, when you roast onions, you're putting them neither in oil nor water. You're just slapping those puppies on the grill right next to your T-bone.
Right.
So how about if it's just pure heat and you get those little brown marks on your
Caramelization.
onions? The caramelization. Exactly.
Oh,
I'd love me
exactly.
some of that. Yeah.
And so caramelization is when you have your sugars, and so that can be either your complex carbohydrates, more your starches, or those can be your simple sugars, which are actually sugars. And so when you go through caramelization, you're breaking down the sugars, you're breaking them into smaller molecules. So you are changing their chemical composition, but I don't think necessarily that's making it better or worse for you, for onions specifically. I'm more worried about cooking your veggies in a lot of oil or fat.
But surely there's some molecules that don't like the heat, and it'll just bust them and break them apart.
Well,
right?
that's different though. That's talking about if you had too much heat. So if you had too much heat, then your molecules are going to completely decompose, like actually break apart, instead of breaking into smaller molecules. So it's like whether or not it's like breaking into more of its elemental states, or whether or not it's breaking into smaller molecules that are still tasty and aromatic and give things the smell.
Still of themselves. Okay, interesting. Yeah. So is that the difference between decomposing and biodegrading?
Well, that depends too. So biodegrading is going to be something that usually happens outside, right? So you have like your, what am I trying to think of? So like 6-pack rings, those need to be biodegradable. And so that's when sunlight hits it. So high energy UV radiation will hit it and trigger some kind of chemical reactions as well. But those are usually photosensitive chemicals.
Okay.
molecules.
Okay. All right. Just checking that out.
Good
All
stuff.
right.
Good.
By the
Similar
way,
though, right? Similar.
Yeah.
It's just different types of energy.
Speaking of water soluble, who knew? Who would have known that the Wicked Witch of the West was water soluble? That's just an interesting little fact. We need some chemists to work on that. I think they got to get some top people trying to figure that one out. What kind of life form is she where that occurs? Right. All right, Chuck, keep them coming.
All right, here we go. This is Brady Feitcher. And Brady Feitcher says, hello all from Los Alamos, California.
Nice.
My question is, in the world of chemistry, is there ever any thought to the possibility that new chemistry might someday be discovered in the way that the physical world is grappling with the ideas of dark matter or dark energy, or in the same realm of possibilities like a chemical world that sort of exists maybe in the quantum realm?
Wait. So Chuck, this is a movie trailer ready to happen. In a world. Yeah, I love that question. So Kate, are we living in the entire one and only chemistry universe?
I refuse to, yeah.
Or can you imagine a whole other chemical realm that is apart and distinct from everything we're doing now?
Yes, and I think it would be ignorant to say that we know everything now for chemistry. I mean, we can't figure out how the electron moves across or from the nucleus. Like it teleports from one side of the atom to the other. We can't figure that out. So to claim that we know exactly what's going on is just gibberish. But I do think we know a lot more than we did 100 years ago. So we've made a lot of progress. I really wish I was going to be alive like 200 or 300 years from now, because I think that's when the chemistry is going to be just like, beautiful.
Wow, that's like a chef does it.
Yeah, exactly.
You kiss your fingers and pop up your hand.
We're back to cooking with chemistry again. That's great.
But wait a minute. So in physics, there are entire branches of physics that were discovered, right? So relativity was a branch of physics, and quantum physics, a branch of physics. So is there a branch of chemistry you can imagine waiting to be discovered?
Oh man, that is such a good question.
I'm just extending the question from our guy. Yeah.
Yeah, I can't put a name to it, but 100%, because I just think we don't know everything right now. I think there's so much more to figure out. We have a decent understanding of the atom, but we still can't see it. Our microscopes are getting better and better and better, but it's not perfect yet. And so I think that we're so close to learning a lot. Like we're right on the cusp. So hopefully we get it soon.
So right now we're playing with atoms, and they're doing stuff we just accept. But we haven't gotten in it to say, hey, I saw you do that, and now I understand it. We just kind of we agree with each other, this is what it does, and we make stuff out of it and move on. Yeah.
We haven't found an experiment to break down our theories yet, but I think it's coming.
Okay.
Wow.
Good.
Okay.
Yeah.
Hopeful.
Yeah.
Very hopeful. Okay, here we go. This is Kevin Ho. Kevin says, hello, Dr. Tyson and Dr. Biberdorf. When we hear the word chemist, we often think of some mad scientist working in an underground lab with lots of different beakers and flasks boiling away. Do either of you know any mad or maybe just kind of crazy scientists in your field?
Kate, other than yourself, is there you need not implicate yourself in this question. You have immunity, diplomatic immunity here. So, yeah, is it possible to know a lot of chemistry and be diabolical so that you end up doing things nefarious?
For sure, 100%. We've heard some really sad stories about people who've taken their own lives because they know enough and they do it in kind of horrendous ways. So I don't like that. I don't like that side. But I do think that chemists in general are quite fun. We usually use our skills for good. So a lot of us, you'll find a lot of chemists in elementary schools.
Okay.
But we're out there trying to promote science, make scientists look good. I want to show that anybody can be a scientist. It doesn't matter who you are, what you look like. But honestly, anybody can be a scientist. If you have a question, technically you are a scientist. So.
Ooh. Okay. And can you be a scientist if you're not simultaneously wearing a lab coat? That's the question.
If you're in the kitchen. If you're in the kitchen, you're cooking, so you do it every night. 100%.
Cooking is chemistry. If it's anything, it's chemistry. Chemistry and thermodynamics as well.
Yes.
Allow me to slip that one in there. Yeah.
I'll take it.
All right, Chuck, let's go into a fast lightning round. So, Kate, you have to answer in fewer than 5 words what your questions are. Give it to me.
Okay.
Chuck.
All right, here we go. This is Gerald Johnson. Gerald Johnson from Seattle. He says, I have reached a scientific plateau. Have we reached a scientific plateau, or has science, discovery, invention just slowed down compared to the days of old? Kind of what you were just talking about.
Yeah. So, yes or no, Kate?
No, we haven't reached the end of that. We just got vaccines. No.
Okay.
She's like, I just got a booster shot. What's your problem? No.
Okay, it's possible that, a lot of advances happen on the frontiers of journals and doesn't always make it into the newspapers. And then there are, Kate, what are they called, who bring chemistry into popular products that just... engineering chemists, chemical engineers, right? Who then do interesting things with it. So yeah. I have to disagree with the person as well. I'm on Kate's side with this. Okay, keep going.
All right.
We took more than 5 words to do it.
Yeah, sorry.
All right. Friedrich Johansson says this. Hello, doctors and lords. team.
Chuck, don't get too accustomed to that, Chuck.
You know what? I got to tell you, at first I was like, oh, God, I can't believe this is... But now I'm kind of like, I like the sound of it. Anyway, Team C's is the initiative to get funds to remove plastic from the oceans. Is there some plausible chemistry as a means of removing plastic and, more importantly, microplastic from our seas?
Yeah. So, Kate, you got like a microbe that would have to include biochemistry, right? Yeah. Some microbes that would munch on plastic and either return it to
and
its
then
base
die.
ingredients and die, return it to Chuck, it'll eat the plastic and then it'll become super microbes. Oh, right, yeah. That would be careful what we wish for here.
Right.
So Kate, what's the future of chemists helping the oceans? I'll give you more than 5 words because we're going to end on this question.
This is hard.
I'm going to give you more than 5 words. Go.
I would say I agree with your answer on that. The only thing I'd be concerned of is any waste that would then be produced in that reaction. So if they're producing methane or producing something else, that could be bad for our environment. I do think MOFs could be the answer. So metal organic frameworks. So they're like those cages we discussed before. So they would essentially trap the plastic, if you will, and then you'd be able to kind of filter that whole thing out in general. So that might be a future, but it's a long way for that one.
Wow. So this is it's an incarceration system where you...
Yeah, I don't like the sound of that.
Yeah, it's not Chuck.
I don't know about that because you know what's going to happen. Now all the black plastic is all locked up. The white plastic still roaming the ocean just as free as they ever was.
That means it's time to end the show. Because Chuck, we can never reel Chuck back when he goes on that way. Kate, it's been a delight to have you. We know we're going to want you back. And my one little I have more, but I would throw out a periodic table tidbit. So we astrophysicists discovered an element on the sun before we discovered it here on Earth. Do you know which element that is?
Oh, God, it's either going to be hydrogen or helium. Helium.
Yep, you got it. So Helios. So we named it after the Greek sun god Helios, and so that was a rare case where we had better data from the universe than we can produce here on Earth. Wow. So yeah, and so that's my one little and I can say I helped. So Kate, we're all going to look for your book so that finally adults can blow stuff up the way you did as kids. Tell me the name of the book again, and where can we find it?
It's Elemental, the hidden chemistry of everything, and it's sold anywhere books are sold.
Anywhere books are sold. That's the answer now. Yeah, that's how that goes. All right. Well, thanks for being a cherished guest on StarTalk, and I assure you this is your first and it won't be your last, provided you agree. Provided you survive, Chuck.
I'll be back.
You'll think you'll be back. All right, Chuck. Always good to have you as
Always
my
a
co-host
pleasure.
here. All right. I'm Neil deGrasse Tyson, your personal astrophysicist. As always, keep looking up.